Hi, this is Mohammed. Now I'm going to explain Python deep learning. It's an ICP 10. So my partner is Vyoma Desai. So firstly, so here for this assignment, we are dealing with the Cypher 10 dataset. So first we will be inputting all the required necessary libraries. And then next we are loading the data. So we'll be getting training and the test data here. So here I was printing the data should shape. Here you can see. And then so actually I was printing one random input data from the training data. So here you can see, so it is in the range like 0 to 255. And so then so for to perform to build the model to provide the accurate to perform better, so what we'll be doing, we'll be normalizing the data from normalizing the data to 0 to 1. So here I was normalizing the data, and then I was after normalization I was printing the data. So here you can see it is in the range 0 to 1. And then I was printing the label for the test data before performing one hot and coding. So here you can see for the these are the labels, like 10 classes are there, so 10 labels. So I was printing that file from the data set. So here I will be performing the one hot and codation. So this can be done by using the function to categorical. So after one hot and coding is done, so I was printing the label. So here you can see, so for the particular label, it will be 1 and the rest will be the 0. So the next step is randomly printing the images of the training dataset, similarly for the testing dataset also. And then from here the main part is here. So as per the requirement, like if the professor is given, so we had implemented the small CNN, we had implemented the CNN model. So here the created the sequential model, and then added convolution layers with a dropout layer, and then also max pooling is implemented here. So max convolution layer, for the convolution first we'll be giving the input size 32 by 32, 3 is the RGB, and then dropout layer max pooling is reduce the size of the images. Then the dropout layer will be adding here, and then finally we'll be flattening the images, and then the dense layers will be added, and then dropout layer will be added, and at the end, so the dense layer is a 10. So actually so it's a multi-class label, so that's why we will be adding 10. And then activation function will be softmax. So softmax is nothing but like so if you are having multi-classes, we will be using softmax. And then next we'll be compiling the model with SGD with the parameters like learning rate 0.1, and then momentum next row. So we are compiling the model with loss function, categorical cross entropy, and then optimize the I told SGD, and then printing the summary of the model. So here you can see the summary, and then finally fitting the model. He was executing the model with the training data set, and then with the approaches 10 iterations, and for each iteration the batch say it will be divided into 128. So here you can see. So after finally the model we got is 73 point. After evaluation, the model we got is like 73. The model accuracy is 73.66%. And then the next step is like we need to convert this same model into the previous model into the Keras functional API. So yeah, it's nothing but like what we'll be doing. So the output of the current layer will be passed as an input to the next layer. For every case, we'll be adding the input, we'll be adding the output as an input to the next layers. So although it is performing the same, so but in the functional API, we will be the main goal is like adding the input functions like multiplying. So you can see the layers, the scenario, everything is same, like adding the convolution layers, max pooling, dropout, and then finally flattening, and then dense layer 10. So and then compiling the model with the same scenario, and then summary of the model. So before compiling the model, so the task is like we need to apply the callbacks to the model, like model checkpoint, reduce error, and then release dropping. So here what we'll be doing, let me explain them. Model checkpoint. So here model checkpoint, all these callbacks will be used in the fit model. So these will be added to the parameter in the fit model. So here you can see the model checkpoint is nothing but saving the weights of a model at some interval, and these models can be loaded later from the particular saved method, so from the particular state saved. So here you can see, so actually what I had done, I had taken each checkpoint, each callback as a parameter, and then I had applied to the fit model, and then I was executed the model. So for each callbacks I had implemented this thing. So I had also done like so I had also implemented like all these callbacks can be implemented in the one variable as a list. So and then the entire list will be passed as a parameter to the final fit model, and then I executed the model. So for the individual what I had done, so here you can see after the comparing the model I got 79%. And then for early stopping is nothing but so actually for the training data set, our goal is to like minimize the loss. Okay, so then what we'll be doing, so whenever the model is trained, so the loss will be like minimized. So for particular for particular if the model is not reducing, then what will be stopping the model. So to overcome the overcome the loss of the overfitting. So that's why, so it will be like multiple runs will be happening, multiple execution will be happening for the data to be trained. So that's why early stopping is need to overcome the overfitting. And then here you can see we can have the parameter as a monetary clause patient free. And then as the professor mentioned, like in the requirement, we need to use the parameter restore best weights equal to false. So we had used that thing. And then after executing the model, and then finally we'll be passing the callback function as a parameter. So is callback. And after executing, I got the accuracy like 80. So like the accuracy is getting increased. And then similarly for the reduced error, and so reduced learning rate will be implemented when the metric has stopped like improving for any particular of the metrics, like accuracy loss, like that. So so finally what I'll be doing, so all these three callback functions I was adding into one variable like my callbacks as a list, and then I was passing this variable, this list variable as a parameter to the entire to the final fit model. So that's the thing I had done. So all the three checkpoints has been implemented in them, has been added as a has been added to one variable as a list, and then finally I will be adding finally I will be adding as a parameter for the fit model. So after execution I got like 74. So what I had done is like nearly, so firstly I had run the model individually, and then later what I had done from the scratch I had executed the model like the implementing the CNN model, and then again converting the sequential to functional API. And then I kept these I had commented these individual callback function, and then and then so like and and at a time I executed the list of all these all these callback functions. So I got like near firstly for the sequential 73 now, and the accuracy 74. And the next one I need to save the model. So this is the function used to save the model. And then next I need to predict we need to predict the 4 images of the test data, and then to print the actual label for these 4 images. So by using the for loop iteration, so what I will be doing. So here you can see for the test data, some test data, the predicted value for the image one is so this is the like the label are in the range, it says a multi-class variable, like so it will be in the range 10. So these are the 10 indexes. So here you can see the actual image. You can see actual value for the image is image 1 is 3. So here you can see the actual what we actually in as in the previous ICP we had used the np.argmax function. So argmax is nothing but like it will take the maximum value from the list, like maximum index from the list. So similarly you can see for all the 4 images, like so here you can see for the image 3 it's like 8, it's the highest one from the predicted image. So as the accuracy is like 75 to 80% varies, so mostly we'll be getting the correct exact images. And then the next task is like I need to download a few of the data set from the Google or by using my own data set. So here what I had done, so for these as common first will be importing the required libraries. And then for this what I had done, I had downloaded cats and dogs images from the Kaggle dataset. So I'm to need, so I need to mount into my Google Notebook. So what will be doing, this is the function used to be this is the code for mounting the data set into the Google Colab, or I can mount into the Google Drive. So this is the thing I had done, and then I was labeling the data image labels square cats and dogs, and then size 128. So I actually the data set will be having like different sizes. So what I will be doing, my common size should be like 128 by 128. So here I was defining a function get data. So get data so that it will what it will be doing, like my data will be like it's not like particular format, it's not like RGB, and then the images is also like not having a particular shape. So this function what will be do, it will be convert the BGR to RGB format and then reshape the images. So for next what I will be calling the functions, and then this is the data set. So this here my so I was this is the path, and I was calling calling the function with the variable path with the parameter path, and then finally I will be getting the training data and then testing data. So here you can see, so I was randomly printing one of the images from the training and the testing data from the training data of cat and dogs. -1, and then here what I'll be doing, I will be normalizing the data here, like it will be in the range the 0 to 255 to perform the model accurately, to build it accurately. So we'll be doing a normalization here, so it will change to 0 to 1, and finally I was printing the shape of the images. So near the for the training images we'll be having 8,000 images with the size 128 by 128, and testing images 2023, and finally so fitting the data. So here image data generator, this is the function is used like this is mainly used to rescale and reshape the data, and also if the image is not like it's a particular shape or any, if it's not like somewhat flip-flop, so it will it will make the data perfect here. So this is the main functionality of the image data generator here you can see. And then as usual I was building the small model, sequential model, like with a convolution layers, max pooling, and then dropout layer, and finally flattening the layer, the dense, flattening the layer, and then also dense layers, and then here the dense equal to, because you're having only cats and dogs, and then compiling the model with the optimizer. We use the ADAM with learning rate 0.00001. The loss function is sparse critical cross entropy, as because it's just in binary classes, so that's why we'll be using sparse category. If it's a multi-class, we will be using a category cross entropy. Finally, we are executing the model with a batch size 128, and then Apache is equal to 100 iterations. So I will evaluating the more, and then here we'll be plotting the graph for the both validation and training data. So with the x as the accuracy, x with the approach on the x-axis and the accuracy on the y-axis. So here you can see some overall good, and the curve training is increasing in the same way validation accuracy is also increasing. So finally evaluating the scores, so you can see 65.74, which is not bad. And then finally I was predicting the images. and the test data. So here you can see the predict function. So this is the cat. So actual label it says 0, as we mentioned 0 is a cat. So this is actually it's and the predicted is 0.59. So this is the highest for the 0th index, it's the highest value. So that's it's a cat. Similarly, so this like one as sub model is just the accuracy is like 68%. So mostly like 60 to 70% will show the correct images. So thank you.